Good morning, everyone. Welcome to the webinar. Along with the development of the internet, the emergence and widespread adoption of social media concepts have changed the way news is formed and published. News has become faster, less costly, and easily accessible with social media. This change has come along with some disadvantages as well. In particular, beguiling content such as fake news made by social media users is becoming increasingly dangerous. Fake news problem, despite being introduced for the first time very recently, has become an important research topic due to high content of social media. Thus lies the foremost challenge to determine the difference between real news and fake news, and to assist you in distinguishing and helping you draw a fine line between the two worlds it seems were rightly tolerant upon perceiving. IEEE NCU Computer Society welcomes you to today's webinar on building a fake news detection machine learning model. I take the utmost pleasure to welcome on board our speaker, Miss Sharmistha Chatterjee. Sharmistha ma'am has several roles carried under her name. She is an alumna of WPUT Kolkata, Alto University, prestigious institutes such as IIM Bangalore and DISS. Counting you probably is one of those rare gems the institution is gratified to, would be rather the apt way of putting it. She keeps a great insight into software technologies and has worked at positions relevant to it in companies such as Wipro, SAP Labs, Simple Software, and Nokia. Currently, she presides over as Senior Manager for Data Science at Publicis Sapient and is a Google developer expert. There are many achievements that can be attributed to this personality, but I do not wish to eat up your time of interaction with her. Dear audience, without further ado, let's dive deeper into the concepts and the subject matter that has been a major concern of India in 2020 fake news detection. Charge up your PCs, acknowledge the links and the data ports mentioned in the chat box, and let ma'am herself apprise you to the need of the hour. And you know the rules. The questions are to be posted in the chat box. Happy learning.
One. Am I visible and audible?
Yes, ma'am, you're audible.
Yeah. So let's start. So what is the setup do you have? Do you have the Python, all the libraries installed in your notebook? Are you using Jupyter Notebook or PyCharm, any editor? Before starting, I think you must be. If you don't have, you can do it in next 2-3 minutes. Before I give a brief introduction of why do we need a fake news detection model, as Yukta have already spoken about it. So in today's world, you in the internet, you see a lot of chatbots in Twitter, news channels, everywhere. You see a lot of chatbots coming in. They keep on posting fake news, as well as they keep on duplicating content. So in order to identify that whether this content is actually a valid content or a duplicated or a fake news content, we would need a supervised model to detect that. So before going into that, I would like to understand that you are all aware of, right, what is a supervised machine learning learning algorithm, and we will then explore into it what are the possibilities we can use into that. Hello? Yeah, so you can type your messages under the chat window. So the supervised training model, we can use naive-based classifier, we can use random forest classifier, logistic regression, or any other things like gradient boosting, all the boosting types of classifier, gradient boosting, ADA boosting, anything. So to start with, we will see that there will be some data. So which data has like along with other attributes, it should have some a text-based column which gives up a full description of the text, which we are trying to understand that is a fake news or a actual news. So I hope you have downloaded the data. I have downloaded the data. So I have downloaded it from your IEEE dataport.org. Have all of you, I guess, are have downloaded the data, right? If not, I post the link again. I received the link from your student chapter to download the fake news detector. So let me post the link again here. Yeah. So here is the data. So data set is downloaded. Okay, fine, great. So there are two datas. There is a news set collection, and there is a fake news set connection, and there is a fake news detection liar model. So you can choose any one of them. So and I hope you are doing with a Jupyter notebook, or you are doing it with your like PyCharm or any editor, Spider editor. So let's load the data. Let's load. So there are three files you can see. One is the training set, one is the test set, and one is the validation set. Okay, so pick, choose any one of this data set and let's load it into the in the pandas data frame. So you can use PD. I'll share the snippet with so let's, where is the chat? Yeah, so put your path and let's load the train data. So df is equal to, so just let me know. Similarly, load the test and the validation data set. Any one of those which you have downloaded, fake news net, or the liar one. There is a fake news detection liar. So any one of those, pick and load the training data set, test data set, and the validation data set. Okay, and then when you load it into our data frame, you will see there is a labels. There is a column called there is a column called label liar. If you have downloaded the liar detection dataset, if you're working on the liar detection dataset, so the output label is dataset is label liar, or you will see another if you're using the other data set, you will see the output or the predicted, what you are going to predict as another label FNN. Okay, so since it is given in text, right? It is given in text, like it could be partially false, partially true. So let's encode that categorically. So we have to encode that variable categorically. So once you are there in this step, I will I will guide you how you can encode that categorical variable. So let me paste the code here. So it is a text-based output label. So let's however you have down loaded into your pandas data frame, let's categorically encode the variables. So just please feel to stop me if I'm going too fast. Otherwise, we can proceed. Let me know if everyone is able to categorically encode this output label. Are we all set? So categorically encode the output level for the trained data set, test data set, and the validation data set. Okay. Okay. So in the data set, you find that we have to predict whether the news is a fake one or is a non-fake, means that's a real news. So which one we are going to predict? There are so many columns. So I will type what are the columns here. So if you see, there are several columns involved in the data set. So I don't know which column, which one you have chosen. So there is a liar data set, and there is a fake news net data set. Okay. Now, if you see, the columns are this for the liar data set. Okay. Okay. I will share my screen. And let me stop the camera. Yeah. Why it is not sharing? Hello. Are you able to see my screen? Yeah. So you will see here, there is a, in the data set, these are the columns. present in the data set. And we are going to analyze this column and predict whether the data set is actually the label is actually fake or it's a true label. Getting it? So are we set? Okay, let me zoom it. Can you see these are the column names? These are the column names. So if you have selected the first data set, these are the column names. If you have selected the other one, fake news, these are your column names. It's same, only the output predicted label, the column name is different. It will be either label liar or it will be label function. Sorry. Are we all set with that? Please the layout of the screen from the bottom right corner. But I have to open this. If I have to... are you able to see my screen? Okay. Okay. So once you have that, just categorically encode. I have given you the full code for categorically encoding the variables. So let's encode the category, do the categorical encoding of the training data. This is the same code. So I'm taking the liar data set. So you have to have the data encoded in terms of 0, 2, 1, 3, whatever it is. So you are going to classify that what kind of fake news is it? Is it first type of it, whether it is a partially fake news or fully fake news, it's a liar news, whatever the outcome of the predicted variable. If you see here, so we have to predict where it is barely true, pants true, half true, mostly true, false, what kind of label the text is, and on what you are going to predict on the full text based content. Okay, so we have to take your X input is what is your X, what is your dependent variable on which you are going to predict the liar label. It is full text based content. So you have to create your train and test data set based on that. Okay, you can also look into the link which talks about this. Let me open that link. So here you see. Here you see what they do. They take, first you have to understand that what you are going to predict. Your DF text is here nothing but your like what I said is your full text based content. In either of the data set, whichever you choose, you will have a full text based content. So I hope you are able to see. I have enlarged my screen. Oh, this is crashing. When I enlarge the screen, it's crashing. Okay, so full text based content. I'll type it here. Don't worry, I'll type it here. So the data. So have you added me on the WhatsApp group? Have you added me on the WhatsApp group? I am not there in the WhatsApp group. How will I share the data? The data link I will send you. I heard some of the guys said that you have the data. No problem. I'll send you the data. You can see my screen, right? This is the data link. Please download the data. Let me know if you can download the data and load the data in the pandas data frame. Please download the data, guys. If you have not downloaded the data, download the data. Type, if you are stuck anywhere, just type it here. Download the data and load it in your data frame. Simple. So train, test, and validation data set. You will have this, the data. There are 3 files into that once you download. So somebody said they have not downloaded. Please send the data on WhatsApp group. So somebody has sent that. Please. So load the data into the, load the 3 files. Load the 3 files. Okay. Let's proceed. Okay. Okay. Fine. So now you have splitted the data. So once you have downloaded, loaded the data, and you have understood which column you are going to predict. You are going to predict the label layer column, whether it is partially layered, it is, or okay, I print what are the values for this column. Okay, see my screen. See my screen. So what I'm doing, I cannot enlarge my screen because it is crashing. Python is crashing if I enlarge my screen. So print this, what are the variables that can come into the predicted outcome, the y variable. Okay, so let me show you. So this has, so see, so these are the outcomes. So this we are categorically encoding in terms of zeros or one. So these are the output variables which we want to predict, whether it is 0, 1, 2. So these we have to encode in categorically, which I have given the code for you. Encode them categorically. Encode those variables categorically, 0, 1, 2, whether it is value, pants, true, half, true, mostly true, false. After we encode it, just split the data set in terms of test and training data set. So this code is this one. So, and what is your X here? So X is your, on your data frame you will have a column called food text content. So take this as your X. So after you are you ready with using the data sets in train and test data? Everybody is ready? Type, I am ready. Just type here if you are ready to go to the next step. Guys, are you ready? Okay, good. Okay, so now we have split the data set. Now check this, what they are doing. I have also done. So you have to use a TF IDF vectorizer. Why do we use that? So we try to find out how many which are the words and how frequently they are present. So TF vectorizer is used to find out if you use noun vectorizers or TF IDF, the frequency of words. And if there are 2 frequent words, like what is the frequency that we are going to use? So it is 0.7%, then 0.7, then we are going to use them. The stop words. If they are less than that, we are going to drop them. Okay. So you can specify your maximum, like 2 frequent words are there, like 100% of the times they are coming in the text. So you can lower the frequency, like how frequently you want them to use it. So this you can say, and the stop word you can say it will take from the English dictionary, or you can, or there is another option how you can do it, is that you can download. You can specifically download, or you can convert them into the same column which you have used, convert them into lower character, lower ASCII character. Okay, lower ASCII character if you want to convert them. So your text is equal to, text column is equal to where text is equal to this column. So somebody asked you to wait. Hope you are done. Okay, okay, let's move. So now you say, and you can also customize it. You can customize it, remove the punctuation. Okay, so you can use this function and remove the punctuation. I will paste the code here. So if any punctuation, if you want to remove from the text, you can do with this code. Clear? I hope you are proceeding. If you get stuck, message me where you are stuck. Okay, you have removed the punctuation. You can also use your own stop words. You can also use your own stop words to remove them. So you can also use this code. Other than which one I have shown the English. Before that, you can also use this one. So these two steps I went back. These two steps should be done before splitting the data and train and test data set. So these two steps followed by the splitting. So I am giving you alternate options. Okay. I'll explain. So you have the full data set, right? You have the data set. Now in the data set, you have full text based content. You have this column, full text based content. That will have punctuations like exclamatory, comma, colon, full stop. All this has you want better. It's to remove. So if you want to remove them, so this code downloads the stop words. Stop words from Encyclical is a library in Python. Okay, that is a pre-learned dictionary which has all the stop words like the semicolon, colon, full stop. So that is a pre-learned library. So you can use that library and tell that if your text has these stop words, please remove them. Please remove the stop words if you take from by matching it from the NLTK based library. So that will remove the stop words. Okay, and then you are also remove the custom code to remove the punctuation. So you can on the data frame, which will be data, and then your I have given you the full text based content is your text. In place of text, you have place full text based content and apply the punctuation removal. So what the punctuation removal will do for every character in the text, if it is not a punctuation, it will join it. Otherwise, it will skip that. So if a character is a punctuation, it will okay. Stop words. Okay, I'll explain you. Stop words are characters in English ASCII-based language dictionary that gives certain meaning to the sentence. So, like exclamatory mark is a stop word. Right? This is a stop word. Comma is a stop word. So, I would write here. What are stop words? These are some example stop words. Punctuations, and there are stop words like these are punctuations and stop words like okay. So we have to remove the punctuations and the stop words from the text. So there are many. So if you want to see, I can Google and show you the total list of stop words in English dictionary. NLTK. So NLTK library has all this. Okay. See the. So what are the stop words? The, in. So these are the stop words. I think 2 is also a stop word. Okay, so after you have removed the stop words, I guess you have can you see this code? You have removed the stop words. You will have a non-meaning. The paragraph will lose some of its meaning. Okay. Can I proceed? Now you can group your group your data, the text. Okay, and based on your based on your the subject will be your label. Okay, so based on the label you can group and plot it to show which are the words which are coming often. Subject, in place of subject, okay, I placed the code here. In place of subject it will be, I will come to that once again. I'll come to that. In place of label liar. So each of these for the label liar, what are the frequent words coming in? Plot it. Plot it and have a look at the word. Now somebody is asking me, is preposition stop word? So preposition in, yeah, it is a stop word. Sometimes we take and there. Some things are also as stop words. So you can download the NLTK dictionary, NLTK library in Python and check what are the stop words they say. And you can of course find your own stop words. If you want that some words are coming to your speak to your team, they are coming in often and often. And if you want to include them as stop words, you can include them. You can specify your own list of stop words. Okay, so now this code, what it will do? Data. So data is your data frame. Okay, so this is your DF underscore train. Okay, DF underscore train and this label layer, you have to group by the data. So this DF train, how do you group the data? So group by, I write, you are able to see my screen, I write one by one. Group by means the data will be grouped by the output labels, and in each output label you want to see what are the English terms, the words, from characters will become to words now. What are the words that are coming often? Okay, so here then we group by this label. Okay, this group by label. Now you are grouped by barely true, half true, false. By you have grouped by this word, by this label, and then you want to see. You want to see in this each group what are the words coming in. So we put a text. What is your text? Your text is nothing but your text is full text based content. Okay, you have to put this. Okay, and then you have to count it. Means you have to count each and every word that is coming to it and count and plot it. Okay, so you count every word, how frequently is coming in this text, and group them in terms of your output label. So barely true, what are the terms of the words that is coming often and often that is causing the text to be barely true, means it's hardly true. Or what is it that is causing, what are the terms that is causing it to be full true? Once again I can show my code. Yeah, so you have it here. So there you have the labels like barely true, pants true, half true. So what are the words that is causing that? So you can plot it by this. There will be a comma. There will be a full stop. Sorry, let me put it here. So you have split the data train and all those things are there, I hope. And then you do. Okay. Okay, matplotlib is not there. Once again, I import that matplotlib. But I have it here. So you have to import these libraries. I hope you are aware of that. You have to import this library to have matplotlib so that you can plot it. Okay. And then I plot it. Sorry, it will come here once again. So it will, after you categorically encode it, split it into 10 and trace data set, you have to plot it. Are you able to see my screen? Any questions? Screen is not visible. Okay, I will share my screen. Hold on. Can you see my screen? Once again. So import it and plot it because it is here. It is Mac OS is it will not from here. So you will get a plot like this. I will zoom my screen, but by charm I cannot zoom. Can you see? Can you see? Are you able to see what is the subject? What you will get value the categorical codes because you have your categorically encoded them. Okay, you have variables like this 0, 1, 2, 3. So for these each encoded variables, you will see a plot like this. What are the terms that are coming in often and often? Are you able to plot it? Yes or no? Yes. Yes. Good. Okay. Good. Now what we have to do? We have to train this. We have to train the data. So this will be again your plots. Now how do you train the data? You have to train the data like this. So train the data. I put the code here. I shared the code. Somebody is telling something. Ma'am, please show above codes. Okay. Here is the code. Here is my code. You have that clear. You have to have the clear idea vector. So you have to import all those things. Have you imported that? These things has to be imported. Yeah, I will give the GitHub links. Yeah. I've shared most of the links. This is done by somebody. See, check the last link. Check the last link where you are stuck. Please check the last link, guys. So here we have splitted the train and data tracer. Can you see my screen, guys? Are you able to see my screen? Yes. Okay. So have you splitted the train and test data set? Are you able to split the train and train data sets after doing the plot? For the plot, you have to check this. For the plot, you have to check this. So your subject will be your output layer label and text will be the full text label that I've told you. The output will be label layer and the text will be full text based content. This code you have to write to plot it. I hope you are everybody is able to proceed. And please explain stop word code. Okay, let's go to stop word. Please type which part you are not able to follow. Let's go to stop word code. Somebody is not able to follow the stop word code. So this is you download the NLTK stop word library. Okay, this is the you have to import first the NLTK library from Python. Okay, and then you have to download the stop word library from NLTK's library stop words. There is a library that you have to download, and then you have to have the stoppers from English because we are doing English processing, processing. So that you are putting it into a variable stoppers dot words dot English. So you are setting those all the English stoppers here. Okay, and then you apply data. Your text again will be your full text based content. Your text is this one. Don't put text; it won't understand. So your text will be full text based content. Okay, put it. So this line, this column is going to get transformed by applying a lambda function. And what does lambda function doing? This is combining all the words except the stop word. So what is doing? Word for word in XSplit. So it's splitting your lines, all the lines it is splitting, and in terms of words. And each word, if it is not a stop word, gets copied to this data. Clear? Who has not understood the stop word code? So this column is getting transformed to a text-based data without any stop words. Understood or not? Jyotin Khurana. Where is Jyotin? Jyotin, are you able to follow the code, stop word code? Okay, good. Now, are you able to split the data in train and test data sets, guys? Have you been able to split the data after plotting? Have you been able to plot and then split the data? Guys, please type Aditi, Bhavna, Yukta. Tell me. Okay, okay, good. Now we have to train the model. See the code. We have to train the model. So how do we train? This is the training part. So you have to have TF vectorizer. So I have given all the list of imports you should have. So this is the list of imports. You should import everything. So these all imports should be there at the beginning of your code. Otherwise, TS IDF vectorizer won't work. So you should have this imports. TF vectorizer, IDF vectorizer should be there. Guys, are you able to do the training? So have this imports and then see, look at this codes. TF IDF vectorizer stop words equal to English, and then you have to transform that X-train. So the X-train is transformed in terms of the vectorizer, and you are testing on the vectorizer. Okay, now that comes the actual training. So you are using a passive aggressive classifier. Okay, and you are initializing the passive classifier, fitting it and predicting on it, and you are printing the accuracy score. So where are we? So are we able to transform the TF IDF vectorizer? Have been able to do this step or not? Tell me. Initialize the vectorizer and transform in terms of the vectorizer. These 4 pieces of line have we able to do or not? Why these? Okay, good question. Okay. So TF IDF vectorizer, what it does, it will count the frequency of the words. For machine learning, you need to rely for training. You need to rely on some input features, right? So what are your input features here? Here is the frequency of the words that are coming in. For any text-based classification, you have the words that are your input features. And how do you notice how these features are getting trained in your model? It's a number of frequency of terms that these words are coming. So TF IDF vectorizer, what it does, it eliminates all those high frequent words which are over the threshold of 0.7, and it converts the each of these words to a vector. It's a number. A word will be converted to a number. How will the machine learning model able to understand text? Say if the text is saying BBC flashes news. Okay, how does it know that each of the words are what? So it cannot recognize. So each word should be converted to a vector. Vector is and in the word embedding. Okay, in the word embedding, if you go for TensorFlow and deep learning based models, as well as there is a word embedding. In TF-IDF also there is a word embedding. So word embedding is a graph. I will show you what is the word embedding graph. Okay. So see word embedding, how does it look like? So this word embedding denotes that what will be the vector value. So see, are you able to see? So it is like a picture. Man is here, woman is here, king is here, queen is here. It's for verb, tense, capital, everything. The words are mapped into a 3-dimensional graph, and where this word, each and every word is located in your dictionary will give it a vector score. It means a number. So So every word has to be transferred. First, the sentence has to be broken down in terms of words, and after removing punctuation, stop words, and then each word has to be represented in terms of a vector, a number, so that the machine learning model is able to understand that. So you will see, if you search by this word embedding, you will see that different words are occupied different places in the word embedding vectorizer model. So camel is here, bird is here, crow is here, and they occupy nearby place if they are similar. So bird and cow are not similar, crow are similar, right? Bird and crow are similar, but bird and penguin is a little bit, it's also kind of bird, but it's not like most words. So penguin is a bit distant away from it. Okay, so pig is to goldfish. No, pig, goldfish is kind of fish, and pig is an entire different category. So pig is so far from goldfish. So any diametrically opposite words like king is to queen, so they will lie opposite to this diagonal line. So are you able to understand what is this TF-IDF? Why do we vectorize? Will you explain? Will you please explain TFE by example? Okay, so TF-IDF, if you see here, so wait, how do I explain by this? So TF-IDF, you have this entire sorts of words, right? And you have these words in your model. Now how do you represent that by TF-IDF? So these graphs gives you an estimation like how the words are vectorized and how frequently they are available. So that is the job of TF-IDF. I don't know whether I'm able to by example. Will you please explain TFI by example? So here is the code which I explained to you. So here, if you see the TF-IDF vectorizer, this is the initializer of TF-IDF vectorizer. Go inside here. Here you will see what is your input. So you should have the input and how you are tokenizing it. If you are tokenizing by space, by default it is space. If you want to tokenize based on some special characters like comma, backslash, front slash, you can use that tokenizer. And then how many maximum features you want to use, you can specify. So if you want to use per word 100 features, you can specify. Okay, if you want to apply regularization, I don't know whether you are aware of the term regularization, you can specify. Okay, and max df that we have used is 0.7, that you can specify. So what does TF-IDF do? It will transform the text into a vector. So this is nothing but what it is returning. See, these are all norms, computes the distances and creates a vector for each word. So every word, the distance will be computed from the nearby words, and it will be represented in terms of the vector. And vector is the number, and it returns that value. Am I able to explain? So you can try out a simple TF-IDF vectorizer in the internet and see how does it work. So let me find out for you. Okay, simple example. Say, take a sentence and then encode with TF-IDF vectorizer. I think we can come back to this. So in the TF-IDF vectorizer, again, you talk about, see, here you take. So are you able to see my screen? I think. So yeah, this is a number of lines. Okay, count vectorizer will count. It is simple. Count vectorizer is much simpler than TF. It doesn't have so many features. So you transfer, it's a similar, but it has less feature. So you initialize the count vectorization, feed transform the document. This is nothing but sense. And then you compute the TF-IDF vector. Now TF-IDF vector, and then you see that what is the weights for these vectors. Okay, so what you do, you transform using the TF-IDF transformer, and you vectorize it. So here they are transforming. Here they are not vectorizing yet. Here now they are here they are vectorizing it. Okay, you get the features, document, transform the document in terms of the TF vector, and you have the scores, like how much it is each of the words occupy in the document. What is the score of the words? It's a vector. Getting it? See, so every word is transformed into a vector, and after that it is analyzed that how much it is weighed, how much it is weighed to that for that word to be present inside that document. So that is weighed and a score is written, a vector score is written for each of the words. Okay, I shared you this link. Once again, somebody is asking some question. I shared this link. So you try it on your own hands and you will get more confidence on TF-IDF vector. Yes, it's a word embedding. It computes a weightage of the words based on the word embedding. Is TF-IDF is a word embedding. TF-IDF itself is not a word embedding, but it uses underneath that word embeddings to compute how similar, how close these words are, and then it computes a score based on its presence in the document and returns that score. So itself, it's not a word embedding. Am I clear? Okay, count vectorization is more simple. It is just count the number of words. You don't have so many features, like you cannot specify what is the percentage of tolerance for high frequency word, what is the percentage of tolerance for very low frequency words. Like where if some words which appear very less in the document, you can say that 5% of the tolerance that you will accompany, you can accommodate, or you can say that which are present very highly, like the, okay, you can tolerate up to 70% of them. Count vectorization does not have all these things available. Okay, so that's the basic difference. So count vectorization, and the most important thing is you can use a pipeline. You can use a scalar scikit-learn pipeline to chain the count vectorization and the TF vectorizer. Okay, so that you can have both of these flavors. Mostly we use TF vectorizer, but count vectorizer for simple to start with, you can use it. It just counts it, and it doesn't have the reverse inverse frequency also. So like what is, if given a lot of documents, if you want to compute the inverse, like what is the frequency of the words in each of these documents. So inverse frequency. So I will give you the definition. What is that? Is called inverse frequency computation with TF-ID vectorizer. So that is not done by count vectorization. Inverse frequency. I'll show you that. So TF-ID vector short term frequency inverse document frequency. That is how important a word is, and it is based on inverse frequency computation. So look at this, study this one. So how this inverse frequency is computed. Count vectorizer is just simple. It will count the number of words that has it, but TF-IDF is more based on term frequency inverse document frequency. So that replaces the how important a word is to a document in a collection of corpus, means you have number of documents. Okay, so it will find out how important it is in each of the documents. So there is a solar kind of architecture that we use in big data that does this TF-IDF in the background and used in search engines. And so the solar, if you look for solar, that you will see that how that it uses TF-IDF to compute the frequency, word frequency, inverse word frequency for each of the documents, and come out with score that the document 1, document 2, document 3, what are the TF-IDF scores. So it will compute this and the proportionality will increase based on the number of times a word appears. And if you want to, and the TF-IDF also has inverse frequency computation, which does with count vectorizer does not have. So it will just count. So here it is, TF-IDF is, if you see this, is frequency inverse document frequency. Okay, so you can look at this and read more about this term. Now let's finish the training part. So 0.7 means what is the tolerance limit that you want to accompany for the words which are appearing too much, like high frequency words that are that are present 90% of the document. So that your model will get biased because of those terms. So we want to reduce, like what is the percentage of tolerance that you want to have for so high frequency words? That is 70.7. That is 70%. Can you please share the GitHub link? Yeah, sure. So I've taken it from here. Run through this code, entire code. Okay, this is a famous code for fake news analyzer. And then also you have this. This is a very simple code. To start with, I will advise you to go through the second one, second option. Second one is simple. So once you have transferred your document to TF-IDF frequency analyzer, then you have for the test, and you have to do for both. So you have to do this for the trained data set as well as the test data set. Okay. So you have to do it for trained as well as test data set. Okay, once you have done that, are you guys ready? You can use a passive aggressive classifier, and in here you can also use random classifier, random forest classifier, ada boost classifier. This classifier can be replaced by, I will show you how. Random forest classifier, ada boost classifier, or gradient boosting classifier. Now I will advise you to use certain libraries which gives best performance. Okay. Okay, I will show you what are the libraries which I have used for my own classification tasks in a different problem. So let me show you that. I hope you are able to see my screen. So use yellow bricks. Yellow bricks gives this Python library gives more good accuracy. Use this library. Okay, use this library. Guys, are you able to follow? Use yellow bricks. You can use passive aggressive classifier the way they have done it here. So they train the passive aggressive classifier. I think you are able to follow it. You can use that, but of course you would want to check this. Yeah, this passive aggressive classifier is not is a kind of a classification algorithm. It is a kind of classification algorithm embedded between scikit-learn, and it's a linear model. So you can use your regularizer and see what are the terms it accepts. It's a linear classification. It's not like a decision tree or not like a gradient boosting. Okay. So it's a linear classifier, and you can specify it, think of in terms of a linear straight line. Okay. And you can specify your regularizer factor, shuffling, all those values. Okay, you can check out what is a passive aggressive classifier. It's a like random forest. I don't know whether you are aware of this. Random forest or ada boost or gradient boosting. These are more advanced classifiers. So they use decision trees like decision tree classifier or random forest. They use decision trees underneath, and they use either they rely on bagging or boosting. So boosting methods like ada boost or gradient boosting you will see much slower because they use yeah, yes, of course you can use naive-Bayes, right? This is good. Yeah, you can use naive-Bayes classifier also, correct? I am talking about different types of classifiers there, and I want you to explore this yellow brick because I have found my models behave. I will show you my models. This is loading 1 second. So you will see my models. If you see, I have got nearly 100% of accuracy with my models with yellow brick. I'll show you. See, my AUC RUC is 80% here with normal classifiers. Okay, this is normal, whatever scikit-learn provides. Whereas when I try to use this yellow brick, when I try to use yellow brick, my AUC, RUC curve, you check. It is 86 to 100% I have been able to achieve. This is with yellow brick. Now, yellow brick, how will you use? Are you able to follow my screen? So this is I got with yellow brick. I want you to try out with yellow brick. This is not overfitting. I'm not able to paste it here. No overfitting. This is the test accuracy. This is the test accuracy. Okay, now how do you use yellow brick? So here how you use yellow brick. So check out this. These are the libraries that has to be imported. Why it is not going? So can I? This chat window is not. Other is not going. Half of the things are not going. Let me. I will send you the yellow bricks. How you can use yellow bricks. Use. Why it is not going? So I give you one line. You. Okay, so from yellow brick you have to import the ROC, AUC, heat and trade, or they have. So my Jupyter notebook is for, this one is for my office work I have done. Okay, so this one is office, but I will share how I have done it. So use this. So you have to use ADA bows, gradient bows. Okay, what is Jatin is asking some question. Jatin, ma'am, for which classifier you always use heat and trail, or they have other methods also? I don't understand your question. Jatin, can you explain what you are asking? Ma'am, for which for check which classifiers always use heat and trail? What does that mean? Heat and trail, or they have other methods also? I don't get your question, Jatin. So what I'm going to say is use a passive aggressive classifier, heat and error method. Okay, you have to use cross validation for heat and error method. I guess you are asking about cross validation. See how I have done the cross validation. I will show you. So yellow bricks is very good in terms of all these things, because I show you how we have done the cross validation method. How to cross validate your data. So you have to plot the feature importances also. So this is the code, you plot the feature importances. So this Google is not taking. Okay, so you should plot your feature importances using seeing the words which are coming more, which are not coming more. Using, you have already done the text vectorizer. Now you have the feature list. With the feature list, you can use any classifier and use the feature importances. Feedback link, please. I don't have any feedback link. Okay, so you send your extrain data, that is the text data which has been removed with punctuation and stop words, and then pass the feature pass your text data into the feature importances, plot the feature importances. Then you will understand which words are coming more often, which are coming less, and then after you have done that, you train your model training code I have already given, and I have given you link to try out the model training. Again, I am pasting the link for model training. Jatin, let me hold a few seconds back. Any link showing complete list of classifiers to understand which classifier for a different real world application of classifiers. Based on my experience and what I have studied, gradient boosting and random forest. All the Kaggle competitions who are winners have used this kind of model. So you can try Googling and finding out into Kaggle where how they have used gradient boosting and random forest. These are the most winning teams who have used gradient boosting and random forest. So trust me, these two works best. But you can of course try out decision tree classifier, try out naive based classifier, decision tree classifier. I have used that. I will share my GitHub link. You can find out how I have used it. I have used in a different context, but for text based classifier, see here I have used different classifiers. Check out my GitHub link. Here I have used for text data, Twitter data, I have used all kinds of classifiers and I found that random forest and gradient boosting works better. Okay, so but to arrive at this, I don't know how much are you confident with text-based classification. Do this problem and see which one works the best. So instead of this passive aggressive classifier, use that, then use naive-based classifier. You can use SVM best classified. Yeah, that's great. You have found out naive based works better. Okay, you can also use random because you have several classes. That's why I'm asking you to try out with random forest. Okay, random forest gradient boosting. Okay, and also you try out with adabos decision tree. So you will know that these are not at par with random forest or gradient boosting. Naive boost performs best. I can understand, but try out everything. So next time when you get any text based data, try out all these things, and then you should plot. No, it doesn't work good if you have multi-class, right? So multi-class problem, logistic regression won't perform that much. I have done it. I have done it. I was showing you here. So logistic regression does not perform that time that better. So let me show you. So if I have to show here also, it takes time. So here, so logistic regression I have used. I have got around 70. See here, 79%. So it was a 72% accuracy here. 72, and precision and recall are close to 65 to 83%. Okay, but whereas random forest I have achieved close to 86, 90% of accuracy. And you have to plot the confusion matrix. Don't forget to plot the confusion matrix. So confusion matrix and AUC RUC curve. This curve has to be plotted. So this is mandatory. You cannot rely on accuracy alone, because accuracy is more of not of a business problem. Accuracy, we try to measure that how many true positives and how many true negatives we are able to classify. But precision and recall, it will give you a correct measure of your false positives and false negatives. So this link has only done, if you see, this link has only computed the accuracy score and left it just like that. But I want you to compute the confusion matrix. Confusion matrix must be plotted. You will see the code here, confusion matrix, and then you should plot the AUC RUC curve. So AUC RUC curve code, I will paste it here. So how do you compute the AUC RUC curve? So this is the code to compute the AUC RUC curve. And cross validation code also I will paste it. I will paste it. So this is the code to how you can do for visualizer is nothing but this is all yellow bricks. This is all using yellow bricks model. All using yellow bricks. So don't use sklearn just like that. Try to use yellow bricks. Please submit. Please answer some Sumit question. Okay, Sumit, what is which performance assay is more important for comparison out of accuracy? No, precision, recall, and F score. Don't even rely on accuracy. Sumit's question answering it. So precision, recall, and F score. Never ever rely on accuracy. Okay, you should compute it, but never ever rely. So I will give you the code using yellow bricks. Copy this code. This is for your plotting the graph for ROC AUC. So I will also give you the code for how you can plot the confusion matrix and how you can do cross validation. So first I will show you the cross validation. Okay, this is the stratified k-fold and this is the cross validation code. Okay, so you will arrive at how many features or how many words you should take into consideration for training. So this is the code for that. So let me paste it here. So this is use random forest. Okay, guys. So use random forest, train, and use five-fold cross-validation or ten-fold cross-validation. So somebody was asking me, I think somebody was asking me, Jatin was asking me, I can't understand your answer of Sumit question. So Jatin, Sumit is asking which one of F score, precision, recall, or accuracy is a more correct metric. So accuracy gives you a measure of true positives and true negatives. Okay, so it cannot give you a correct measure of precision and recall. So why do we need precision and recall? So precision gives you a measure of how many of the uh, say how many you have classified correctly. So you have some, say x number of samples which has to be classified into your class 1. So precision gives you that out of recall gives you, whereas recall gives you whether you have been able to classify all of them correctly. Precision gives you that out of how many of other classes you have also classified at the number of false positives, that is given by precision. So you can check out the definitions. If my explanation does not seem good to you, you can check out the definition. But for any business use case, we take into consideration precision, recall, and F1 score. These three things have to be computed, because precision gives you a measure that how many of the false positives, like some of the other classes you have also considered while labeling your classes, you have done something correctly, but it may so happen some other classes you have also labeled into your class which is not correct. So precision, it will give you a measure of this, and recall will give you like how many of you have missed. Suppose you have classified 10 samples into your class 2, but there are actually 20 samples which you should have been classified into class 2. So I have missed 10 samples to correctly classify into class 2. So recall will give you a measure of this. So you should always look for recall and precision and compute the F1 score to arrive at a conclusion which model is giving you a best result. As well as in addition to this, you should plot the AUC RUC curve, the code which I have shared with you. ROC AUC, how do you plot the curve? So this one will give you a measure that where is your cutoff, how much percentage of your curve is under the AUC. So it is 86% or 90% or you are getting 60%. So these 4 things you must do to validate which is your best model, the best model selection. Ma'am, which is more, one is more important comparison? Jatin, am I able to answer your question? Jatin, please type. So any more questions you have, guys? Where are we? Okay, so where are we with the code? Are we able to classify fake news or not? Please answer. Akash, Lakshmi, Aditi, Bhavna. I want to hear, where are we? Are we able to classify the fake news or not? Where are we stuck? Tell me. Guys, where are we stuck? Are we able to classify 0 or 1 and compute the accuracy or not? Guys? Okay, Lakshmi is telling yes. So you are able to compute the accuracy. Okay, good. So any questions, put it in the chat window. So if anybody got stuck anywhere or not able to proceed, I have shared the code. This code works full and you have to replace, you have to try with yellow bricks. Yellow bricks code I have shared. You should use yellow bricks. It's a very good Python library. And try out random forest, gradient boosting, ADA boost, decision forest, and see which model gives your best result. And everybody, if you have learned something, put your code in GitHub. Put your code, everybody should put their code in GitHub. So it will create, before you apply for campus interview or you try for applying for jobs, it will create your image, it will create your brand that you are able to do. Recruiters want to see that how much you have done by your own self, how much code you have written. So everybody wants to see. Don't just digest the knowledge and say that I know. Everybody should put their code in GitHub. Okay. So that will help you to get job fast. Good jobs. Everybody wants to see what you have done. So questions. Guys, question. Any more question? Where are we? Any more? Mahima, Mohima, Akash, Yukta, Jatin, you were asking a lot of questions. Please ask. Where are we? Jatin? Jatin, Srivarsha. Who else is there? Rakesh. Rakesh. Any questions? Anywhere you are stuck or not able to do? I'm waiting for questions. Everybody's saying yes. Yeah, please ask. Jatin, please go ahead. Ask your question. No, too many features is not good way to proceed. Ideally, you should it should be within six. Within six is good. More less features you are able to use is more good. No, yeah, you should not use 10, 15 features. How can we select which classifier is good? So there are open source libraries that selects which classifier is good. Okay, otherwise you use yellow bricks or skykit. Yellow bricks I would prefer. Use all the cross validation. First you have to, okay, I'll write it down. First use cross validation with all the models and select the best classifier. How do we, okay, ma'am, can you explain, okay, one second, Rakesh, ma'am, can you explain how to initialize a passive aggressive classifier? Oh, passive aggressive classifier, it is here. It is just, you have to import the correct library. I will show you how to import. To answer your question, Rakesh, you initialize it like this. And how do you import that passive aggressive classifier? You have to import it like here. I have during the start I showed the imports you need. So you import it, import the passive aggressive classifier and then initialize it. Okay, and then somebody is asking, Shashank has asked a question. Yeah, in machine learning less features are good and in deep learning works good with many features. Yeah, deep learning is for that. Deep learning, you don't have to do any feature selection. The CNN models, the kernel, the filter you specify, the padding, they will do the feature selection for you. They will find out the edges. They will find out how the contrast is changing, different layers, the convolution maps it will create, and deep learning we leave it to the model itself to do the feature selection. But in traditional modeling, you have to do the feature selection by itself. Ma'am, what if a data set has 2 or 3 text columns and other are numerical columns? Okay, 2 or 3, do categorical encoding. Lakshmi Priya, categorical. Text columns means, do you mean text column means, I assume that you are talking about something small text like say probably false, like this. If you have small text, okay, then use categorical encoding. I have given the code. I can give you excuse me excuse me, I can give you the code for this once more. Always do categorical encoding. Sumit is asking a question. In feature extraction, what are other methods than TF-IDF? For feature extraction for text-based classifiers, we rely on TF and IDF. For LSTM, use LSTM. TF-IDF for traditional ML text-based classifiers. For deep learning DL models, we use LSTM. LSTM word embedding. Rely on pre-trained word embedding also. Pre-trained models like Globe. Okay. Number features. Sumit has asked. Lakshmi has asked. Jitin, what is okay? Jatin Khurana again. She is asking and again a question. Is there by visualization for feature? Yeah, there is a way for visualization feature selection. So plot the feature importance. See how have I done it. Check this code. So I have tried to plot for Adabos. There are 7 features which are getting used. Whereas for random forest, the same one. For random forest, I'm using 6 features. So there is a play to plot the features and see how many features which model works best. So all these functionalities comes with yellow brick. You won't be able to do those so many things with scikit-learn alone. Okay, this is the confusion matrix. I hope everybody has the code for confusion matrix. So this is the code for confusion matrix. I'm pasting it here. Okay, code for confusion matrix. Confusion matrix code. Okay, confusion matrix code. Figure is equal to, sorry, the conf mat, eliminate that conf mat. Fig is equal to plot figure. From there it starts. Okay. Yeah, correct. Programming how? Yeah. From you have to hear, ma'am, what is the word cloud? Okay, word cloud. Somebody, I will come to word cloud. Somebody is asking one more question. I will check. Okay, Jatin has asked one question. Is that by visualization for feature selection classifier? Another visualization is there. So you have to go to, let me show that. Then I will come to another, somebody has asked a question. So there is a feature importance plot. So this is a feature importance plot. Okay. So when you select the feature importance, you can plot them. So this is the feature importance plot. So this is how you see how the features for which model. Select a model inside here, which model you want to select, random forest or AdaBoost or whatever, and do that. What cloud? I will say come back. Okay, this is the feature importance plot. Jatin, ma'am, what is word cloud? Word cloud is out of so many word vectors that you have used. Okay, words coming into your document. You try to see what is the general trend of the words. So which say you suppose I am plotting election sentiments from Twitter. Okay, so frequently the words which are coming in are government, Modi, PM, prime minister, vote. Okay, so these are, so based on the importance of the word, in the word cloud, its size increases. Okay, so the most prominent words are visible at a higher size, at a higher font, at the center. And as words importance decreases, they generally, their size diminishes, and as their frequency diminishes, their size decreases, and they surround the center words, though, which are most prominent words come at a larger size and at the center. Okay, so more questions? Any more questions, guys? So if you are not able to do or stuck anywhere, you can still mail me. My email ID is, and I have some samples done in the, not the fake news detector, but other things which are done inside my GitHub. So I have COVID-19 time series analysis done, many other things done. You can check my GitHub. Okay, somebody is asking, Sumi, any specific hardware requirement for branding so that they can be run on normal PC? So it's based on the size of the data and the number of features. So if you are trading billions of rows, you can use, say, I will say Amazon, so 16x large, starting from 16x large AWS SageMaker. These are still CPUs. After that, you can use, GPUs. Okay, so you can how much ever you want, you can scale, use that. But first, say if you have hundreds and maybe few millions, I will spare for you. You can go with CPU. Screen not visible. Okay, let me share my screen. I don't know why it is not visible. Stop presenting. Present now. Yeah. Okay, somebody is asking, ma'am, can you please send all of the classifier which important and regressor list also. So I will write it down here. Decision tree classifier, decision tree, random forest, AdaBoost, gradient boosting. But remember, all who have won't Kaggle, gradient boosting or AdaBoost, naive base, passive aggressive, these are just trying out. So when you try out, you know that these also doesn't work well. random forest, gradient boosting, ADA boosting. Yeah. Then you try ensemble modeling. This is very important. Ensemble model. I will put it in quotes. So you chain the classifiers, means you combine them. How do you create an ensemble model? Ensemble model is somebody, sorry, Kanak Kumar. Okay. Can you send me concern material through email? I'm not getting what material are you looking for? Ensemble model is weighted use of multiple classifiers. Means, suppose, can you please explain? Yeah, XGBoost is also important. XGBoost, light GBM. So I will add, sorry. So weighted use of multiple classifiers means 0.70% of random forest and 0.30% of gradient boosting. So this is ensemble classifiers, okay? And KNN logistic I won't specify unless you have 0 and 1. If you have multiple classes, don't use KNN logistic. No. KNN logistic is only for 0 or 1. So if you have binary class, go for logistic. Simple thing you have to do fast binary classification. Okay. Somebody has asked me XGBoost. Yes, XGBoost to add to my list, add XGBoost Light GBM. Okay, Light GBM and XGBoost. Light GBM is developed by Microsoft. Okay, Light GBM is developed by Microsoft. Try out. So it is very fast compared to XGBoost. Okay. Somebody is asking logistic follows one versus reset. So logistic regression, since you have talked about, so in you will come across problems where you have to do anomaly detection. So there you use SVM1 class classifier. Okay, this is SVM1 class classifier. It is an unsupervised algorithm. So read out this. What is SVM1 class classifier? So this is another common classifier mechanisms, but not for multi-class classification. Never use that. Okay, these last two are never for multi-class classification. Okay, so acha, Kanak Kumar, you wanted me to send some mail concern material through mail. Can you please explain what you are looking for? If I have, I will send. Kanak Kumar, is he there? Kanak Kumar? Yes, NavBase, yes. I have listed all the classifiers. Okay, I am once more time listing it. I will list it once more time. See, here I have put NavBase. Put it XGBoost, Light GBM. Also logistic for one class classification. Logistic regression classifier. But this is for 0 or
Hello.
1. Hello? Yeah?
Yes मैम, एक्चुअली मैं लेट से ज्वाइन किया,
Okay.
तो मैं पूरा पिकअप नहीं कर पाया, इसलिए मैं बोला आपसे कि अगर आप
Tell me what you are looking for. You tell me please what you are looking for. I will try to help you. Tell me. What material?
I want to know about I want to code.
The fake news detection model, right?
Yes ma'am, yes ma'am.
Okay, I will share with you whatever I have taken from some people who have done on GitHub. I will share all the links, and as well as I have done little bit of it, I will share that with you. Okay, if that helps.
Okay, thank you. Ma'am.
So which the mail ID I am using for communication, I will send there. Okay.
Okay, ma'am. Okay, ma'am. Thank you.
Okay, thank you. Any more questions, guys? Where are you stuck? KNN. I am not very willing to put it KNN. Okay, I will put it KNN. See, because KNN is more of an unsupervised algorithm. Okay, we use KNN over for supervised classification. So look at these. Keep this master list. No, linear regression. No, linear regression is a regression. It's not a classification. No. So keep this master list with you guys and try out whatever problems you get from Kaggle or dataset you get. Try them out and see which one works better. Okay. So any more question, guys? Guys, any more question? So Sumit is asking one question, man. Please also tell type of. Okay, Jatin, I am coming back to you. Sumit is asking a question. Is supervised not better than unsupervised not it is changing as well. No. So see, what is the type of problem you are solving? Based on that, you have to take it. For classification tasks, we go for usually supervised. If we have label data, we will go for supervised. If we don't have label data, there are mechanisms which is called semi-supervised algorithms, or we rely on deep learning adversarial training. Adversarial training, I don't know whether you are aware of, it uses discriminator and generator to generate samples, and the discriminator constantly tries to fool the generator, the generator tries to fool the discriminator, and discriminator tries to diminish which is real versus fake. So that depends on, again, on labeling. They try to label the data based on generating samples, but mostly for classification problems which are supervised, we use this, and unsupervised you can use different types of clustering. So let me list that. Unsupervised, before I come to Jatin's question, unsupervised, all types of clustering starting from k-means, k-center, k-midoids, k-medians, then spectral clustering, db-scan. There are some more I can't recollect now. So spectral, db-scan. Spectral is different, db-scan. So that is for all unsupervised types of clustering. Okay. What was hierarchical clustering, hierarchical clustering, agglomerative clustering. Okay, these are all important. So for unsupervised, okay, is unsupervised not, we cannot say based on which is better, unsupervised or supervised. So it's based on the problem you are solving, how much data you have, and also what are the features which are playing. If you have some features which are directly correlated to the target variable and they are playing better impact, then maybe unsupervised will work better. But it is again based on what is the input data that you have. Okay, now going back to Jatin's question, regressors. Okay, how much accuracy you can obtain? You can obtain 90%, over 90% accuracy, better than 90%. Okay, regressor. Regressor is same thing, random forest, they also have regressors. All these classifiers will have regressors also. Okay, it's the same thing. Let me copy from there. And logistic regression, linear regression, polynomial. So it's all using L1, L2. Don't forget about L1, L2 the penalty terms. What is that called? L1, L2 regularization terms. Never ever forget that. Okay, regularization. You will be asked in interviews what is the difference between L1 and L2, and which one is most pass and which one is not. So these are usual questions for interviews. So these are the, I am not sure XGBoost has a regressor. I have not used any time. Let me check XGBoost has a regressor or not. Yeah, XGBoost. Yeah, there is an XGBoost regressor also. So LightGBM, I'm not sure. These are the regressors. So linear regression, you will get, linear and logistic regression models, you will get a lot of varieties like polynomial with lasso, elastic net, okay, with lasso and elastic net both combined. Okay, so these are the things you should try with, and then you go on to this other things what we have talked about classification. They will also have the regression models. SVR, what is that SVR? SVR is what? I've heard of SVR. What is that? I've forgotten. Let me check. What is that SVR? SVM, we know. SVR is, yeah, support vector. Yeah, support vector, epsilon support vector regressor. Correct. Correct. Yeah, correct. Any more question, guys? We are close to 1.5 hours. Any more question, guys? You can write to me. You have my email ID. You're there with LinkedIn, with me at LinkedIn. You can add me at LinkedIn. If I know, I will try to help you out. So this is my LinkedIn. So this is my LinkedIn profile, and I have a website. I write blogs. So this is the website. I have shared my GitHub link. I will share my website. I've done COVID-19 analysis, and there are many more things are there. Fairness, differential privacy, TensorFlow, many things are there. You can check out my blogs. Okay. And if you have any feedbacks, please feel free to share. Any more questions, guys? Yukta, any more questions? Mahima, Wahid, Srivasha. Are you able to make something out of today's session or not? I didn't have to go for PPT because PPT is like people speaking it instead of hands-on. So I didn't go for PPT. So how do you rate today's session 1 out of 10? Please put your ratings. It will help me to improve. Rate. Good. Somebody is telling 10, 11. Okay. So what are the improvements? You can put it here. I will try to. Other dataset repository apart from Kaggle. Okay, ma'am. My screen is why stopping. I don't know. So I have some data sets in my repository like GitHub. Check out my GitHub, which I try to do it. Try to learn something and put it in my GitHub. So I have put the elections 2019 elections. You will find it COVID-19. Some data I have done from April to June. Some analysis is there. So take it out. Okay, sure. Connect. Let me connect. You can send me an email, or I will reply to you to the email. Give me some time. I will take a break. Maybe in next 2 to 3 hours, I will reply you back. Okay, sure. I will give you the code. I will try to help you. And if you need anything more, let me know. Get connected in LinkedIn. We can, if there is anything, I can help you. To be glad. Okay, go through my blogs. There are some latest like deep learning blogs on how do you predict COVID-19 and fairness data set. Like there is TensorFlow has come up with, but fairness, different libraries have been developed by IBM and all. How do you ensure unbiased model training, fair models, machine learning models? Okay, so you can check that. Okay. Then if no more questions, we can disconnect. I will reply back, connect, don't worry. Okay, thank you. Thank you, guys. Let's stay connected. Okay, thank you. Bye.
Thank you, ma'am, for the incredible session. Constant webinars has gotten to the nerves of the techies who have always wished to lay their hands on empirical entities. You've been a great guru all this while and made us vulnerable to the concepts in such short period of time. IEEE NCU Computer Society would be forever grateful to you for honoring us by addressing the event as a guest speaker.
Yeah, thank
A
you.
wholehearted thank you. To the inquisitive patient mentees who have made this a successful one. Our team would be pleased if you could take out some time to fill the feedback form whose links has been shared in the chat box. Thank you all once again. Stay safe and take care. Thank you, ma'am.